Hey guys, so welcome to lesson 14.2. We are going to talk about the properties of fluids. So there's a couple laws that we're going to talk about and how that affects the fluidity of things that we deal with in everyday life. So the first one is called Archimedes' principle and buoyancy. So have you ever seen massive ships on the ocean or a river and wondered how can these things possibly float? So when you look at a ship floating on a body of water, there's actually a force you don't see pushing up on the actual ship. The force that actually pushes up on the ship is called a buoyant force. And the buoyant force is something that opposes gravity. So gravity pulls down, buoyant force pushes up. So if the buoyant force equals the weight of the object, then the object will float. But if the buoyancy force is less than the object's weight, then the object is going to sink. So what is buoyancy? Buoyancy is, as it says in this definition, it's the ability of a fluid, whether it is liquid or gas, to be able to exert an upward force on an object that is immersed in that liquid or gas. So let's talk about Archimedes' principle a little bit more. There's two things that you need to know. First of all, back in the day, in about 3rd century BC, there was a mathematician named Archimedes, and he is the one who discovered buoyancy. He discovered the force of it. And what he found was that the buoyant force on an object is equal to the weight of that fluid that is displaced by the object. Meaning, if you put an object inside of, say, a cup of water, the amount of fluid that gets displaced when you put that object in that cup of water is going to be equal to the weight of that object. For example, if you look, so like I said, if I put a piece of wood, like you see in the picture, into water in this cup, the water that's going to be displaced or pushed out, it will actually be the same amount of what the wood weighs. When the weight of the water displaced equals the weight of the object, in this case the wood, it's going to float. So in this case, the wood is floating because the weight of the water displaced is equaling the same amount as the wood, the weight of the wood. So if the weight of the water displaced is less than that of the block, the object sinks, aka what we see happening to the steel. So when you compare buoyancy and weight, what we see is, if you look at the image, right, you have a piece of wood floating in water. You can see that the amount of water displaced and the weight of the object is going to be equal. But both wood and steel are actually displacing the same amount of water. Therefore, both have the same buoyancy force. But the only reason the steel is sinking is because it's actually heavier. Because the steel is heavier, it's going to have more of a gravitational force pulling on it, so therefore it's going to sink. So now let's talk about density and buoyancy. So if an object is going to float, that means its density is less than the density of the fluid, all right? So in order to figure out if an object is going to float or not, you have to compare the object's density to the density of the fluid that it's placed in. The object is going to float, like I said, if the density is less, if the density of the object is less than the density of the fluid. Remember, density's formula is density equals the mass of an object over the volume. Therefore, if the density of the steel in the cup on the right is greater than the density of the water, then the steel will sink, which is true in this case because the steel sank. So let's look at this ship. The reason a ship that's made out of metal can actually float is because it has the steel that makes it up spread out more and takes up more volume, and therefore it has a bigger mass. And the air that fills up all of that open space inside of the steel ship is also going to be a greater amount. Therefore, if you look at the overall density of the ship with the large amount of steel spread out over a larger space and the air that fills it up, you are going to have the entire ship be less dense than the water that it's actually in. Therefore, the boat is going to float. So, in summarizing, steel boat has more volume and air. Therefore, it's going to be less dense than the water. Therefore, it's going to float. Okay, so Pascal was actually a French scientist, and one of his discoveries was that he found out that when you apply pressure to a fluid, that pressure is actually going to be transmitted throughout the entire fluid. So one of the examples is squeezing a toothpaste. So when you squeeze the toothpaste at the bottom of the tube, the pressure goes through the entire fluid, which is the toothpaste, and therefore it comes out through the hole at the top. So what is pressure? When you have pressure, it's basically a force per unit area. That's the equation. So pressure is measured in pascals, force is used in newtons or measured in newtons, and then area is going to be measured in meters squared, also known as P equals F over A. When you look at yourself right now, right? Technically, you have air pushing on you from all sides, just like you would if you were submerged in water. You would actually feel water surrounding you on all sides. And therefore, that's why the definition for pressure is force per unit area. And then make sure you know all the SI units and use it correctly, as well as the equation for it. And we're going to do some practice problems using it so you understand how. So the first practice problem is the atmospheric pressure at sea level is about 101 kPa. So that's kilopascals. With how much total force does Earth's atmosphere push on an average human being at sea level? Assume that surface area of an average person is 1.80 meters squared. So let's take a look at how to do this. Okay, so in example 1, we want to first write down the equation. So remember, we said that pressure equals the force, which is measured in newtons, over area, which is measured in meters squared. So we know that the pressure is 101 kilopascals. Now, they tell us the pressure is in 101 kilopascals. But when we look at the measurement for pascals in pressure, it's only pascals. So what do we have to do to get from kilopascal to pascal? We have to convert. So remember, 1,000 pascals is 1 kilopascal. So we simply multiply 101 by 1,000. So we would get pressure is 101,000 pascals. Now, we also know that the area is 1.80 meters squared, but we need to find what force is, okay? If you hear my baby in the background, she is cooing and it's adorable, so enjoy it. So now that we have this equation, let's plug it in. So we know that pressure is 101,000. We don't know force, and we know that the area is 1.80 meters squared. So in order to do this, we need to multiply 1.80 with 101,000 to get it on one side so that we can get the unit F by itself. So 101,000 times 1.80 equals F. Remember, if you are dividing on this side, you do the opposite on the opposite side, so you would multiply on this side. So 101,000 times 1.80 equals the force. You multiply that together and you get 182,000 newtons, which is the unit for force. Therefore, that is going to be your answer. All right, problem 8 says, a diver who is 10 meters underwater experiences a pressure of 202 kilopascal. Again, here's a kilopascal. Make sure that you convert to Pascal when you're plugging it into the equation. If the diver's surface area is 1.50 meters squared, with how much total force does the water push on the diver? Let's figure this problem out. All right, so for this problem, let's again write down the definition that we have, the equation, not definition, for pressure. So pressure equals the force over the area. So in this problem, we know that the pressure is 202 kilopascals. We need to convert that to just pascals, which means that we need to do 202 times 1,000, because kilo is 1,000. So we're going to get 202,000 pascals. So this is going to be our pressure. Then we need to find out what force is, because we don't know what it is. And we know that the area is 1.50 meters squared. So let's plug this into the equation that we have up there. Pressure, we're going to put 202,000 equals, we don't know what force is. We know what area is, 1.5 meters squared. So if we are dividing on this side, we have to multiply on this side, right? So we do 202,000 times 1.50 equals the force. This multiplied is going to give you 303. Oops, let's write that a little nicer. 303,000 newtons. Don't forget that unit is going to be your force. And the 10 meters that they referred back in the problem, that does not matter in this case because we don't need to apply that to the equation. In problem 9, it says, a car weighs 15,000 newtons and its tire is inflated to a pressure of 190 kilopascals. Again, conversion. How large is the area of the car's tires that are in contact with the road? So here, obviously, is the answer. Let's figure out how to get 0.079 meters squared. So in this case, we're looking for the area, not the force. Okay, so let's start off by writing the equation. Pressure equals force over area. And let's write what we know. We know that the force is 15,000 newtons. We also know that the pressure is 190 kilopascals, which if we convert to just pascals, we do 190 times 1,000 because a kilo is 1,000, and that's going to give us 190,000 pascals. And we don't know what the area is. Now, this problem is going to require an additional step to what we did in the previous problems. So let's plug it in. So we have 190,000 for our pressure. We know that our force is 15,000 newtons, and then we do not know our area. So in order to get A by itself, we have to do a couple moves. We want to get A by itself to figure out what A equals. So the first thing is, on the right side, we see that A is being divided by 15,000. If you're doing division on one side, we're going to do the opposite to the other side, which would be multiplication. So moving A to the other side, you would get 190,000 times A equals 15,000. Now, we still have to get A by itself again. So how do we do this? So if we're multiplying on this side, we have to divide on this side. In order to get A by itself, we have to leave A on this side. So A equals, and again, if we're multiplying on this side, we have to divide on this side. So it would be 15,000 divided by 190,000. And that is going to give us 0.078, or if you round it up, 0.79 meters squared. Do not forget your units. Okay, now I did skip the challenge problem, because if you guys can do the challenge problem and email me your answers and you get it correct, I will give you extra credit for that on your next quiz or your test, okay? So make sure you email it to me with your answer for extra credit if you want to give it an attempt. Okay, so now we're going to talk about Pascal's principle, which basically is, Pascal's principle is, if you have pressure, it's going to be transferred through a fluid, and this is the equation for it. So the pressure in is going to equal the pressure out, and the formula is force in over the area in equals force out over area out. So let's take a look at that. Now, there's something called a hydraulic lifts. This is usually used in auto repair shops when you have to move something really heavy, and they use Pascal's principle for this. So if you look at the image on the left, you see a pipe that is in between two cylinders, one little cylinder and one big cylinder. This pipe is filled with fluid. Now, the pipe that's connected between the small and the large cylinders, there's going to be a pressure that's going to be applied in the small cylinder, which is going to go through the pipe and through the fluid into the larger cylinder. So in a hydraulic lift, you use your weight to lift something bigger / heavier than you by applying pressure to one area, and it gets transferred throughout the fluid into a larger, to cause something bigger to be lifted. So let's look at a couple problems. So the first problem is, a hydraulic lift is used to lift a heavy machine that is pushing down on 2.8 meter squared piston, which is going to be your area 1, with a force of 3,700 newtons, which is your force 1. So the question is, what force, so we're figuring out force 2, needs to be exerted on a 0.072 meter squared piston, which is your area 2, to lift the machine. So let's figure out how to do this. Okay, so for problem 2, we're going to first always write out the equation. So force 1 over force in over area in equals force out over the area out. Okay, so let's write out what we know. We know that force out equals 3,700 newtons. We know that area out equals 2.8 meters squared. And we know that area in equals 0.072 meters squared. Now let's plug in what we know into the equation. So we know that we don't know force in, so we're going to leave that there. We know that area in is 0.072. We know that force out is 3,700 newtons. And we know that area out is 2.8 meters squared. So we need to get force in by itself. So we're going to have to do a couple cross multiplication rules. So let's do that. So in order to cross multiply, we're going to cross multiply these two, and then we're going to cross multiply these two. So we're going to do F in times 2.8 equals 0.072 times 3,700. Now we have to get F in by itself. So we're going to do F in. Remember, whatever's happening on one side, we do the opposite to the other side. So if we're multiplying on this side, we have to divide on this side. So F in equals 0.72 times 3,700 is going to equal 266.4. We're going to divide that by 2.8. Therefore, Fn is going to be 95.1. Or if you want to round it up, 95 newtons. Okay, problem 11 says a car weighing 15,000 newtons is on a hydraulic lift platform measuring 10 meters squared. What is the area of the smaller piston if a force of 1100 newtons is used to lift the car? So the answer is going to be the answer is going to actually be 0.73, not 0.073 meters squared. So make sure you know that, and I'll show you how we get that. Okay, so for problem 11, let's write down what we know. So the first thing is we know the equation is Fn over An equals F out over A out. We also know that Fn is going to be 1,100 newtons. We know that F out is going to be 15,000 newtons. A out is going to be 10 meters squared, but we don't know, oops, that's going to be an A. We don't know An. All right, so let's plug this in. So Fn is 1,100 over An, we don't know, equals F out, which is 15,000 over 10 meters squared. Again, we are going to cross multiply and see what we get. So 1,100 times 10 equals A n times 15,000. Now we have to get An by itself. So how do we do that? First, we're going to simplify on the left side. 1,100 times 10, we are going to get 11,000, which is going to equal 15,000 times An. Now we have to get An by itself. So for multiplying on this side, we got to divide on this side. So it'll be 11,000 divided by 15,000 to get An by itself. If we simplify this, we're going to get 0.73 equals An. And don't forget the unit, which is going to be meters squared. Let's talk about Bernoulli's principle. So Bernoulli, his name is Daniel Bernoulli. He was a Swiss scientist, and he mainly studied properties of moving fluids such as water and air. And what he found was that the velocity of a fluid actually increases when the flow of the fluid is restricted, meaning it somehow you're blocking it off. So this is something like if you've ever had a water hose and you're watering something and you put your thumb over the opening, you are restricting the flow of the fluid through the opening, and the velocity, you can kind of see that the water coming out with a little bit of the opening that's left is a lot faster than when it had the entire opening available to it. So when opening of the hose was smaller, water flows more quickly. He also found that as you increase velocity of the fluid, the pressure of the fluid actually decreases. So this is what we basically talked about. Placing your thumb over a running garden hose demonstrates this effect of Bernoulli's principle. When the opening of the hose is decreased, like putting your thumb over it, the water flows out more quickly, and that's being shown in the picture. Now, let's talk about viscosity. Whenever you think of viscosity, you might think about syrup or molasses. That's what I do, at least. So first of all, viscosity is the resistance of a fluid to flowing. So all liquids flow, but they flow at different rates. So when we talk about viscosity, we're really talking about how well that liquid is flowing. It's how much there is resistance to a liquid that is flowing. So for example, if you look at syrup and you're pouring syrup, nice cold syrup fresh out of the fridge, and you're pouring it over your pancakes, the flow of the syrup is actually going to be pretty slow. But if you heat that syrup in a pot or a pan over the stove and then you pour it, it's going to be a lot faster. So temperature does impact how much viscosity a certain fluid can have. Water flows easily because it has low viscosity, meaning when you have low viscosity, that means you have less resistance, therefore more of a flow to that fluid. If you have a high viscosity, that means you have more resistance and that fluid will flow more slowly. So, the reason this happens is when you, for example, tilt a bottle of syrup, the flowing part of the syrup that starts to make its way out of the bottle is actually going to transfer energy to the stationary part of the syrup and start to pull it down so that it begins flowing. So it's kind of like a pulling mechanism. This flowing fluid will transfer energy to the non-flowing part of the fluid and start to pull it down. So when you have high viscosity, you have high resistance to flow. When you have low viscosity, you have low resistance to flow. Which is a unit of pressure? Kilopascals is a unit of pressure, but when you use the formula, which is P equals F over A, remember that pressure is calculated in pascals. So if you see kilopascals in your word problem, you have to convert it to pascals. What does the upward arrow in the diagram represent? So what is the upward arrow here representing? It is representing C, the buoyant force, which goes against gravity, which is represented by the downward arrow. Which uses Pascal's principle? Pascal's principle is applied to hydraulic lift, which is what we talked about in auto repair shops when you are able to apply your weight to lift up a much larger and much heavier object. All right, that's it for this section. I will see you guys in the next.